Hello everyone! We're continuing with trigonometry problems, and today I've got another nice one for you. As you can see, we have a triangle here, and it's divided into two parts, a yellow region and a blue region. Here's what the question says. Triangles ABC and BCD are both right triangles. Two angles are given to be equal. Angle BAC and angle DCA are both x. We are asked to find the ratio of the area of the yellow region to the area of the blue region in terms of x. So how do we solve this? Angle DCA is x, and let's call angle DCB y. Then x plus y equals 90 degrees, right? That means angle DBC is also x. To make things easier, let's assume that the length of BC is 1 unit. Now, the length of DC would be sine x, because sine is the opposite side over the hypotenuse, and since the hypotenuse is 1, DC equals sine x. By the same logic, dB would be cosine x. What about segment AC? If you look at the larger triangle, triangle ABC, and if angle BAC is x, then AC would be cotangent x because cotangent is the adjacent side over the opposite side. And we already assumed that the opposite side is 1. Alright, now we have all the information we need to find the areas. Let's call the total area of triangle ABCT. That would be cotangent x divided by 2. Let's call the area of the blue triangle M. That would be sine x times cosine x divided by 2. To find the area of the yellow region, we subtract the blue area from the total. Let's call that S. And we are asked to find the ratio of the yellow area to the blue area. That would be S divided by M. Let's simplify this expression. As you can see, there are a lot of 2's in this expression. They're in both the numerator and denominator, so they cancel out. Now take a look. Both the top and the bottom have sine x times cosine x, so we can simplify the whole thing. Cotangent x divided by sine x times cosine x minus 1. Now remember that cotangent x is equal to cosine x divided by sine x. If we plug that in, the cosine x terms cancel out, and we're left with 1 divided by sine squared x minus 1. Let's move the minus 1 up into the numerator. That gives us 1 minus sine squared x divided by sine squared x. Now here's the most important identity in trigonometry. Sine squared x plus cosine squared x equals 1. You can actually see this identity on the blue triangle here. So instead of 1, we write sine squared x plus cosine squared x. When we subtract sine squared x, we're left with just cosine squared x. So now we have cosine squared x divided by sine squared x, and that is exactly cotangent squared x. And that's our answer. So what do you think? Was it hard? Well, we did do a few steps, but I tried to write everything out as clearly as possible. I hope it made sense. See you in the next lesson.